Good morning. This is Cody Hendrickson, and today we're going to be looking at how we can prepare for the AP Computer Science Principles exam, specifically the Create task, by identifying abstractions in code. And so let's go ahead and take a look at this. So first we have right here the dictionary definition of abstraction, so we can see what it is. And if we look at this English definition, we see that it's the active process of abstracting, the state of being abstracted. Defining something with itself, basically recursive definition without a base case. Oh, no, not going to use it. That's not what we're looking for here. Let's try the dictionary.com definition, a little bit better. The act of considering something as a general quality or a characteristic, apart from actual concrete reality, specific objects, or actual instances. An impractical idea, something visionary and unrealistic. No. In fact, we actually use abstractions in computer science to make it more practical, more realistic. We can get a better explanation of what we're doing. So let's switch on over here to the computer science side. We have a great definition over in Wikipedia. And we have the process or feature of using data types to perform data abstraction to decouple usage from working representations of data, structures within programs, and the concept of procedures, functions, or subroutines which represent a specific way of abstracting of control flow in a program, aka we're figuring out how we can represent what we're going to do with stuff. Very practical, totally not unrealistic. It's in fact a great way to look at what we're doing. So let's actually see how we can use this inside the AP Computer Science Principles exam and do some work with that. So first thing we have right here is the actual rubric that you're graded on. We're looking at the AP Computer Science Principles Create task. And if we look at that right here, we have the selected code segment as a student-developed abstraction, aka you wrote it. So this is something that you actually have to write. This isn't something that just like, you copied off the internet or you found it out of a text or something like that. No, this is something you wrote for your project. So it's actually very important. That's the key component right there. Then we have to look at the other side. And we're using existing abstractions to create a new abstraction, like creating a list to represent a collection, like a classroom, an inventory, a restaurant, a hotel. Be creative, make some fun things. Having a whole palette of colors, all sorts of cool stuff. That's what's going to earn that point. So the student is creating something that represents something else. We're creating a way of making a better representation of data inside our project. Now, we have a couple of specific examples we have also from the rubric right here. And again, if you have that big purple book, you can see the more detailed on this. But we have procedures, also known as methods, parameters, aka the things that go inside the parens on a method, lists, we've been using those for a little while, as well as APIs or application program interfaces, things we use to actually do cool stuff inside projects, as well as libraries that exist either inside the language you're looking at or get brought in from an external library to go and do some cool stuff as well. Now we can also look at the fact right here, it says that listen to their data collections be treated as an abstract data type or an ADT when we're talking about developing the programs. And this is where we can use some really cool advanced features inside programming. This is where you get the idea of the angle bracket type that you might see inside your C++ or Java languages or even Swift like that where you're doing developed structures on your own. But that's a little bit above and beyond what we're looking at most of the time. We're talking about the abstractions for our CSP project. So don't stress about that as much. Well, again, what we have right here, we'll look at that first thing right there. Responses use an existing abstraction to create a new abstraction, like creating a list to represent a collection, aka you're making something that can do something. So it's a way of representing in your code, a better way of understanding what you're doing. That's what we're looking for when we're talking about the computer science principles abstraction. So we have some examples right here, and these are all taken from the released examples off of the College Board's website. If you just go to collegeboard.com and go to the information for the AP CS Principles page, you can find all of that right there. That's where all these are extracted directly from, so you just log in right there. On example A, we have right here, we have the sample of the rolled set random color method that takes an object chicken as an array of chicken objects as a parameter, and then assigns all of the chickens to be a random color. Oh, hey, what we were just talking about, we make a palette of colors and we assign to chickens. And so this is student-directed code. This is not something that came automatically part into. There was not a chicken that came with Alice. That's not part of the actual language. But it's a way of actually putting together a piece of information that we can do something with that. So this is the abstraction that the student put together. As you can see, they earned both points for this when they were graded. And we could look at the actual written assignment that goes along with that. We look at this, when we look at this, we see the student chose their set random color method specifically. They identify their abstraction explicitly. That's one of the key things we have to make sure that we do on our assignment. This method uses math to set a random number. Each of the chickens are used in my game. The method then uses the logical if-else statements. Oh my gosh, we're using logic. Hey, wasn't there something about that in the create task earlier when we were talking about we have to use math and or logic? Part of the algorithm, that's right. These things are closely related, so keep that in mind that we have to use that logic in there, and we keep that up as we go throughout the end project. And assign different colors to the range of numbers that are given to the chickens. This abstraction helped manage the complexity of my program because it ensured that I would not have to put together the large amount of code every single time I called the method. Otherwise, I'd have to have this pile of code. Oh, I want to change the colors of the chickens, boom, pile of code. I want to change the color of chickens, boom, pile of code. We're able to remove all of that by simply using a defined method that I wrote, or you wrote in this case, to actually use that right there. And so when he calls set random color, that does all the work again for that. And so because of that abstraction, you have to rewrite the same 10 if-else statements more than once because you can call that existing method. So again, One of the key principles we have when we're working with abstractions is something that you wrote, and it saves the amount of code that you have to write over time because you can then use it as a call inside methods and do it again and again and again. It's a way of managing the complexity of your program. It makes it easier to do and do cool stuff as part of your project. We next have example C. So the example C also earns both points, and we have right here, we have a for each loop going through all the cards inside a card list, and it has a method called addObject that takes CXY as parameters, abstract away the details. We don't have to worry about that. Then numCard++, if the card is equal to 4 or 7, then we're going to set some specific values to the X and Y position. Otherwise, X goes up by 210. And so we have on this one, this student specifically is getting their abstraction. They're creating a list of 9 cards to apply the abstraction. We have a list. Oh, that's one of the things that was just back there on the rubric. We've got this. And so that iterative process going through the list increases the efficiency. We don't have to end every single card to the background separately. Again, we're talking about the way that we can make this code work better because I can do all of this now with this block of code we have right here. This identifies an abstraction where I can save time and effort in my code, not simply saving the effort in the game, like, oh, I only have to click the buttons many times. No, it's actually making the project work better designed. My project is more effective. And then the student further adds to that, by saying, for example, the program has already added 3 cards. It must know that it needs to start the second row. Also made variables for X and Y coordinates. If the counter variable equals 4 or 7, I have to add 230 to the Y coordinate and reset the X coordinate back to 105. So it's a way of resetting those values so it can go and put the cards where they want them to go inside their game. Great way to organize their code, and they understand how it's impacting what it's doing. So again, the first part identifies an abstraction, in this case using a list, and then it does stuff within that in a way that makes the code more effective and organized. So another way we can get both points. Here we have a block-based code also earning both points for the abstraction. And so we have a block called define position, so we're defining a type of position, and it says go to XY for the specific position, and then set that size to 10%, and then show. So when that position block gets called, it's going to perform that set of actions. And so this student is creating a bowling game, and they realize that when the bowling ball touched the pin, they program it to hide, go back to position, set the original size to 10%, be visible again. They're doing that work over and over again. And so again, we have the idea that we're noticing that we're repeating code. We're doing something over and over again that we can be simplified and have something that actually makes it so our code is easier to understand by doing something. I myself would not define position. I give it like, reset or something like that for its name, but we have the right idea right here. We're actually defining our project and making it so it can work better, and then so we can redo it over and over again rather than have to rewrite the code over and over again. And they figured out, again, that if they made a custom block called position, they could fit all those blocks into that position and then make it an abstraction block. So they identified at the end that this is the abstraction. And that is a key component within the actual exam, that you have to identify that this is the abstraction. This is how you made your code better and simpler within the actual structure so it can work better for you. And they helped me significantly is ensure that every time I look at the code, I wouldn't get confused. Again, that's one of the key things of the abstractions, that will help you as a programmer better understand the code itself, make it easier to understand. And that's one of the great things we can do within abstraction. Now, on the other side, we have an example right here where we're going to earn 0 points. In this, when touching sprite, or sprite 2, forever, I'm going to move speed plus 2 steps and create a clone of myself. Now, unfortunately, this isn't really much of an actual abstraction. This person abstraction is caused the snake grow each time it eats an apple. This is done by creating a new clone of all the snake each time it eats the apple. This abstraction also increases the speed of the snake each time it collects the apple. This causes the snake to be more challenging to get the apple also over the edges. Well, they're just explaining what's going on inside the code. They're not actually providing an explanation of the abstraction, not saying how it is an abstraction. And then on top of that, it doesn't abstract the code. It's not actually performing it, because this is actually just right here. This is just a handler. This is just an event-based action. This is built in. This is not something the student wrote. They just plugged some blocks into there. There's a way to make something be more interactive with the user, and it's a great thing to do. It makes the programming have a lot better options. But simply saying, oh, when you click the button or you touch the thing, this happens, that's not an abstraction. That's simply just using a pre-built-in library. And again, that's not student-directed code for an abstraction. So this lost both the points. It didn't identify abstraction in the visual component right here, and it also did not have an actual explanation of how it was the abstraction or how they worked to make that the abstraction. So it fails on both points on that. So you want to make sure you actually develop the code yourself, number one, and number two, you have to make sure you actually explain how it's an abstraction. We have another example of how it earned no points over here on the left, with example H from this directory, with example H from the student samples on the College Board website. And so we have a comment right here, if wrong answer is click leads back to beginning. On event, oops, click function event, set string Q1. This again is just a non-GUI example of what we just saw earlier. All this is just an event handler. It's not an abstraction at all, and in fact, it's just simply like, oh, click. There's nothing here. This is not complex enough to be an abstraction. The abstraction itself needs to actually provide some benefit to the programmer and stuff. And then we look at the actual definition that the user provides, and the purpose of my program is to educate and encourage people to learn foreign languages. Oh, great. To do that, my game quiz asks questions. The user must select one of the 4 answers, one in Spanish, one in French, one in Japanese, one in German. Because repetition is key for learning a new language, I decided to incorporate it in my program. Except for 3 questions, the user types in a response. The rest are multiple choice questions. For each question, there's only 1 correct answer, so when any of the incorrect answers is clicked, the game over screen comes up. On that screen, the user clicks a button to try again. The trick of the game is that every time an incorrect answer is clicked, it brings you back to the first question. This program code segment allows the game to work as a constant loop, always waiting for the game screen over to appear. That's not an abstraction. It's deciding what's going on behind the scenes of the entire project, not this method right here. This is saying, oops, click, function event, screen, set screen Q1. That's all that's happening. It's just doing that one action. This is not an abstraction at all. So we have to make sure that our definition that we're providing for that abstraction actually explains how this is an abstraction. This is talking about the overall project itself. That's not what the point of that question is. The point is to describe how it fits as an abstraction. So the ones that earn the points, going back to that really fast, we have a quick, oh, I have an abstraction right here because I made it so it makes the code easier to understand and compresses the code I have to write. I have an abstraction right here because I now have a method that I can call and do cool stuff with that. I have an abstraction right here because I created a block that I can reuse over and over again, and it helps make my code easier to understand and easier to explain what I'm working on. These are great examples of abstraction, and they explain them inside the actual written part. These two, however, don't have an abstraction at all explained in this one, and this one also doesn't have an abstraction because it's simply just explaining that it's going to make the game harder, and that's not the purpose of an abstraction. So wipe those out. We also have example I, a text-based example where we're earning no points, and so we have right here the abstraction is the blue rectangle right here, saying line 9 to 10 subtracts 1 from countdown displays the value, and countdown equals countdown minus 1, set text countdown countdown. Well, that code, not an abstraction. Subtracting 1 from a number, no. That doesn't make your code easier to understand. It doesn't provide for explanation of any information on that. It doesn't allow you to enhance your program, add details, provide a better explanation for, or allow you to incorporate new and cooler ideas. No, it's subtracting 1. Doesn't cut it. We look at the actual written components they provide. The blue rectangle's image showcases a code segment which implements a mathematical function of the program, which is developed independently. Well, that's great. This code takes a value given from countdown to the user to drop-down box, or code get text from line 4 subtracts 1 from it. After so, the code segment displays the result from the countdown slot on the screen. This code segment is part of the function that serves as an algorithm to repeat the code segment. Without the code segment, this whole program would not run, as there would be no segment giving the means to subtract or reach 0. Therefore, the displayed value would always be 1 input by the user. Okay, that doesn't talk about abstraction at all. It does say they developed it themselves, woo, but the problem is that's not actually providing the functionality of an abstraction. And then on top of it, take a look right up here, on event. It's a button handler. We don't do this. This doesn't count. And we're going to talk about this here in just a smidge. So let's take a look right here at an example. We have 2 chunks of code on our screen right now. We're using a block-based example from App Inventor. We have a change random color method right here where we're going to do some changing colors to the screen 1, and every button inside a button list, we're going to go ahead and change all of their colors as well. Or we have the web color change button dot click call random change or call change random color. So we have this one, or we have this one. Which one is the abstraction? This one right here is just a click event. It's just clicking the button. That is not the abstraction. However, the actual method that I wrote, that I developed, that makes it so I can do things more often, do cool things, and enhance my code, as well as provide a simplicity for understanding how my code can be accomplished and have provided functionality increase, and make it so I do provide the functionalities of giving the abstractions, as we saw in that first thing where I can represent data in new ways, is handled right here in purple with the method. So the method itself will work as an abstraction. The event handler, or the call to that method, not an abstraction. So we want to make sure we look at it that way. The code we write and that we can define and structure, that's where the abstraction happens. Now, I'm going to show in a text example right here using some Java, which one best shows the abstraction and why. So we have right here 4 different samples. We have our public static void main string args, and we have samples, new sample code, sample.does stuff, public void does nothing, public sample code does nothing, call inside that was system.println, this is my abstraction, and public void does stuff, real and purposeful algorithmic code that accomplishes the intended things. Now, it's pretty obvious, but let's take a look at these. Public static void main string args. No, not the one. Public void does nothing. Literally an empty method? Come on. It does nothing. It's not accomplishing anything for us, so it's definitely not an abstraction for us. Sample code, the constructor for this, it calls does nothing and prints this is an abstraction. Just because it says abstraction doesn't mean it's an abstraction. However, does stuff right here, does stuff provides something. It's doing functionality, even though I'm purposely not showing a whole bunch of code because, again, I'm wanting to actually not, give off some stuff right there. It's like, hey, this is a great abstraction, but I'm showing what's going to actually happen and doing some stuff. You can see that based on the comments that I provided for the actual code right there, it's real purposeful algorithmic code that accomplishes the intended things. Because, again, we have to actually have a project that does something. So, giving you a quick little blurb right here, the best I can do without actually giving away too much. And so that's the answer we want to look for. So, just as a quick review, big things we want to not do. Event handlers are not an abstraction. So in JavaScript or code.org's curriculum, we have like the onClick or the onEvent. Those are what they're usually called, where it's the I click the button or this thing happened inside the app itself. That's not what we're looking for. In Java, what's inside the action perform method of a button click event, also not an abstraction. In Swift, things linked to IB action or in some built-in methods like view-to-load, again, also not actions because those are predefined things that are part of the actual language itself or the handler that we're looking at. Again, not the abstraction. The code that we create, that we write, that makes it so it's easier to understand things, that's where the abstraction happens. These things right here on the left are all part of what's built into the actual language and not the actual happening. For Android, the onCreate would be opening window screen. For Scratch, the when flag pressed. App Inventor, canvas.flung, image_right.dragged, things you would see inside your game. Great, cool things you can do amazing stuff with, but not the abstraction. The abstraction needs to be written by you. So again, something that is built into the language or the library doesn't count for that. It happens at a specific time already. It's already got stuff working on the scenes behind that. Yes, for strict definitions, it's an abstraction, but it's not your abstraction. And so we want to make sure we have that right there. You need to also design this yourself. So make sure you're writing some code that you use that's going to be helping your project make more sense, to provide more functionality and or depth to your project. That's where you're going to be finding the abstraction you can use with this. Finally, we look at how to explain that abstraction. We do that written part. Now, this is a thing that you will want to be practicing on, talking to your teachers as well, looking over the rubrics and stuff to go into more detail on that. But you want to make sure, how did this selected piece, chunk, code, block, whatever that I'm working with, make my project easier to update, enhance, and or change? Because those kind of things are where we can see the abstraction very easily. Oh, I made this method, it let me so I could add more weapons to the game. I made this method, it made it so I could do cooler dance moves on the screen. I made this method and it made this other option happen. I made this new abstract class type, and so I can have this kind of thing, and this kind of thing. Oh, I'm making more data sets. I'm making a data structure that can represent all the information that say scores all for the game or whatever we're working with. These are all cool, amazing things that can link for that, and that's what you want to look for on that. Look for how you use your parameter or parameters to change the state or the internal concept of what you're working with. A great way to handle abstractions there as well. You also want to look at how the methods or the custom blocks, if you're using a block-based language, that you use and or call multiple times. Oh, I have a loop that calls this all the time and it's really important for my game. Maybe that'd be a great thing to look at for what I want to use for actually identifying as the abstraction. I'm not saying it's going to be it, but it's a great place to start looking. And especially, one of the best ways to actually find this, look for a data structure, a thing that you made to hold things, to model something real. When you use that to identify something that's real within the code and you can explain that, almost always it's a great way to show a high-level abstraction inside your project. Again, for a quick review, make sure you identify what the abstraction is. It's going to be some code that you wrote as part of your project. Make sure you clearly identify it. Oftentimes it's going to be involving either parameters, methods, or data structures. Those are the three best things to look for. And then when you write about it, make sure you clearly identify how it's an abstraction and how it actually enhances the structure and or readability of your project. These are some great ways you can make your project do better. Have a great time, and I hope to see you do a fantastic job on this later this summer. Thanks, and have a good day.